Welcome students. So in previous class we have covered the topic of oblique impact and we have solved one problem. In today's class we will see another case wherein we will be required to find out what is the velocity of the ball dropping from height h1 to height h2 in n number of bounces. The coefficient of restitution for this case wherein the ball is dropped from height h1 to height h2 in n number of bounces is given by the relation E is equal to h2 by h1 raised to 1 upon 2n, where E is coefficient of restitution, h2 is the final height attained by the object, h1 is the initial height of the object, and n is the number of bounces. Now let us see an example. Let us say this is the ground and there is a ball here, this one, and this is dropped on this surface. So after hitting this surface, this ball will rebound, and after rebounding, let us say it reached to the height of this one. Then again it will come down here, and again it will rebound, and it will be reaching some height. Let us say this much height. So initial height of this ball, dropping height was h1, and final height was h2. In how many number of bounces? In 2 bounces. So in this case, the value for E will be h2 by h1 raised to 1 upon 2n. Let us solve some examples based on this. The question is, a ball is dropped on a smooth surface from which it bounces to a height of 4 meter, and on the second bounce, it attains a height of 3 meters. Find coefficient of. So it is a similar case which we have seen in previous slide. There is a smooth surface here, and the ball is dropped on this surface from a height of 4 meters, and after, let us say, 2 bounces, this has reached to this height h2, which is of 3 meters, and we need to find out what is the coefficient of restitution. So we'll apply the formula E is equal to h2 by h1 raised to 1 upon 2n. Here h2, that is final height, is given to us as 3 meters. h1 is given to us as 4 meters, that is initial height, and n is number of bounces. So it is given to us in question that on second bounce, that means the number of bounces are 2. Just substituting the values, I will get answer for E as 0.93, and this completes the solution. So it's quite simple. Just you need to find out 3 parameters: h2, that is the final height, h1, that is initial height, and n, that is number of bounces. Let us solve one more problem based on this, which says a ball drops from a certain height and after rebounding twice from the floor reaches the height equal to half of the ceiling. Find coefficient of restitution. So let us start with the solution. Again, here let us say there is a ceiling and there is a floor, and the ball is dropped from this height. Let us say this height is h. So it is said to us that when this ball is bounced here, after 2 bounce, it reaches, let us say, somewhere here, which is at a height of h by 2, half of the ceiling, and we need to find out coefficient of restitution. So starting with the formula of coefficient of restitution as E is equal to h2 by h1 1 upon 2n. h2 is final height. Final height, it is given to us as half of the ceiling, that means h by 2. h1 is h, that is the initial height, and number of bounces it is given to us in the question as on the second bounce or after rebounding twice, that means n will be equal to 2. Substituting the values for h2 as h by 2 and h1 as h, and n is equal to 2. So if you see here, this h and this h will get cancelled, and I will get answer for E as 0.84. So with this we have completed our solution and thereby completed the topic on kinetics of particles 3, popularly known as impulse momentum. So hope you have enjoyed the topic and you are now confident enough to solve any problem which comes from this topic. Thank you.